Suppose I ask you to analyze the limit of geometric sequence. So, solution. A geometric sequence can be written this way. R to power n. Have I seen this before? Yes. In pre-calculus, we had, for example, 2 to power n as geometric sequence. The common ratio is 2. Okay, so what about this guy here? We know that from algebra, f of x equals to a to power x is an exponential function. We know the behavior if a is more than 1. The function is increasing. So the limit in this case goes to infinity. Limit of a to power x as x goes to infinity is infinity. However, if a is bounded between 0 and 1, your graph starts decreasing. These are what we saw in intermediate algebra. The limit in this case, in this scenario, as x goes to infinity, becomes 0. Now for a geometric sequence, a to power x, which is equivalent to r to power n, we have the following. The limit of r to power n as n approaches infinity can be written this way. If r, or the basis, is more than 1, it goes to infinity, but if your r is bounded between 0 and 1, it is going to be 0. Now I expect you to ask, what if r is equal to 1? These are important notes. If r is equal to 1, what do you have? You have 1 to power n, which is basically writing the terms of the sequence as 1 and 1 and 1 and 1. So if I graph this guy, take a look at the graph. No matter what n is 1, an is 1, n is 2, an is 1, n is 3, an is 1, n is 4, an is 1. So it keeps repeating itself at 1. So in this case, if r is equal to 1, the limit of r to the n as n goes to infinity is 1. We don't have any other option. We don't have any other choice. Very good. So another question that I ask you to analyze a sequence, you need to consider all possible options. If my r is a negative small value bounded between -1 and 0. For example, if I have r equals to -0.5, that is absolutely fine. I can create this sequence. Why not? What's wrong with this? R is bounded between -1 and 0. In this case, the limit of absolute value of r to the power n as n approaches infinity is the same as limit of absolute value of r to power n as n approaches infinity, which is basically 0.